Hello and welcome back to Chopstick Maths. In this video, we shall solve a problem from the chapter of exact differential equation, exercise 1, sum number 5. The given equation is 4x plus 3y minus 4 dx plus 3x minus 7y minus 3 dy equals to 0. Now comparing this equation with m dx plus n dy is equal to 0, we have m equals to 4x plus 3y minus 4 and n equals to 3x minus 7y minus 3. So, let us first prove that this equation is an exact differential equation. For that, we'll have to take the partial derivative of m with respect to y and then take the partial derivative of n with respect to x. And if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x, then we can say that the given equation is exact differential equation. So let us first start and take the partial derivative of m with respect to y, that is del m by del y equals to 4 del by del y of x plus 3 del by del y of y minus del by del y of 4. Now, whenever you are taking a partial derivative with respect to y, you have to treat x as a constant. So, since x is a constant, del by del y of x would be 0. So, this would be 4 into 0 plus 3 del by del y of y is 1. So, it is 3 into 1 minus del by del y of 4 is again 0. So, that would be del m by del y equals to 3. Now, n equals to 3x minus 7y minus 3. Now, taking the partial derivative of n with respect to x, that is del n by del x equals to 3 del by del x of x minus 7 del by del x of y minus del by del x of 3. Now, since we are taking the partial derivative with respect to x, we treat y as a constant. Therefore, 3 del by del x of x, del by del x of x would be 1. So, it is 3 into 1 minus 7 del by del x of y. Now, since y is a constant, del by del x of y would be 0. So, it would be 7 into 0 and del by del x of 3, 3 being a number, del by del x of 3 would be 0. So, here we get del n by del x is equal to 3. So, now let us call this 1. Del m by del x is equal to 3. Let us call this 1. Del n by del x equals to 3. Let us call this 2. So, from 1 and 2, we can see that del m by del y is equal to del n by del x. So, we can now say that the given differential equation is an exact differential equation. So, now having proved that this equation is an exact differential equation, let us now proceed to find the solution. So, the given differential equation is 4x plus 3y minus 4 dx plus 3x minus 7y minus 3 dy is equal to 0. So, the solution is integral of m dx keeping y constant plus integral of n dy integrating only those terms which are free of x, that is equal to c, where c is some constant. So, from here we can see that m is 4x plus 3y minus 4. So, this would be 4 integral x dx plus 3y, since y is a constant, it would be plus 3y integral dx minus 4 is again a constant. So, it is minus 4 integral dx. Now, n is 3x minus 7y minus 3. So, while integrating n, we have to integrate only those terms which are free of x. Now, the first term has an x, so we neglect it. The second term is minus 7y is a term which is free of x. So, we integrate that, it would be integral minus 7y dy, and the last term minus 3 is also a term which is free of x. So, we integrate that, we write it minus 3 integral dy is equal to c dash. Now, rewriting this 4 integral x dx plus 3y integral dx minus 4 integral dx. Now, getting the minus 7 outside, it will be minus 7 integral y dy minus 3 integral dy is equal to c dash. Now, the formula that we'll be using to integrate this would be integral of x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. So this would be the formula that we would be using to carry out this integrations. Now if you see 4, x is x raised to 1, that would be x raised to 2 plus 2 plus 3y, integral of dx is x, so it is 3y into x, minus 4, integral of dx is x, so it is minus 4x, minus 7 integral y, that will be y raised to 1, so it will be minus 7 integral of y is y square by 2, so it is minus 7 y square by 2, and again integral of dy is y, so it is minus 3y is equal to c dash. Now we can write this as 4x square by 2 plus 3xy minus 4x minus 7y square by 2 minus 3y is equal to c dash. Now the LCM is 2. So this would be 4x square by 2. So multiplying and dividing 3xy by 2, we get 6xy by 2. Multiplying and dividing 4x by 2, we get minus 8x by 2. Minus 7y square by 2, and multiplying 3y and dividing 3y by 2. So we get minus 6y upon 2 is equal to c dash. Now writing it with a common denominator, we get 4x square plus 6xy minus 8x minus 7y square minus 6y, the whole upon 2 is equal to c dash. Now transposing the 2 on the right hand side, we get 4x square plus 6xy minus 8x minus 7y square minus 6y is equal to 2c dash. And rewriting 2c dash is equal to c, that is some constant c. So we can write this as 4x square plus 6xy minus 8x minus 7y square minus 6y is equal to c. And this is the required solution of our given differential equation. Thank you very much for watching.